Okay, looking at example 9, differentiate y equals the cube root of tangent of x squared. This is basically the same level difficulty as the last one. It's going to have multiple chain rules happening, but it's not quite as obvious. First thing I do notice is my radical here. I don't like to differentiate radicals, and hopefully you guys don't either. So I'm going to go ahead and start with that. Y equals. Now, we're taking the cube root of tangent of x squared. Be careful that x squared is the argument of tangent. Tangent of x squared itself is to the first power. So when I'm creating this fractional power out of this thing, the radicand of this cubic radical is tangent of x squared. And that's being raised to the first power, so 1/3 power is what we're going to get out of that. So again, be cautious that you get the proper fractional power out of that. Some people are tempted to put 2/3 because they see that squared on it. But again, that squared is part of the argument of tangent. It's protected by the parentheses, so the 1, which is understood to be there, over 3 represents the fractional power. So the overall type of problem this is a power function. We have some object to a power, so the power rule is going to be the differentiation we're going to use to start off with. So y prime equals 1/3 times the same argument, tangent of x squared, to 1 lesser power. 1/3 minus 1 is equal to negative 2/3. Alright, then the base of my power expression is tangent of x squared. I have to differentiate tangent of x squared. Tangent is the function type it is. Differentiation rule for tangent is secant squared. So I'm going to get secant squared of x squared. And that's not just tangent of x, it's tangent of something that has a derivative. So secant squared of x squared is the derivative of tangent of x squared, but then the derivative of x squared is 2x. Alright, again, x squared is a basic function, derivative of x squared is 2x, that's the end of the chain rule. Once you get to a very basic type of function, x to a power, some trig function of x, that's when you don't have to go any further. Now, and this one, again, I can't make that look a lot more pretty than the other one, but let me try a little bit here. So I'm going to go y prime equals, alright, first off, secant squared, x squared, and 2x are all on top, so 2x secant squared of x squared. And 3 and tangent of x squared to the 2/3 are on the bottom. I'd probably leave my answer like that. If these powers matched here, secant squared of x squared and tangent of x squared would be complementary. They both have the same arguments, so some cancellation possibilities there to make it a little bit prettier. But honestly, I'd probably leave it right there. If the powers, if this was just tangent of x squared, not to the 2/3 power, I might try and get some of this tangent and secant simplified down a little bit, because secant's 1 over sine, cosine, tangent's sine over cosine. They're both over cosine, so cancellation possibilities there for sure. But the fact this is a 2/3 power, this is a squared, those don't work very well together for cancellation. They're probably getting prettier than what I've got right there to try and make it any prettier. So I would probably stop right there.